I was going up from town, I met the grain trains rolling down. Every day 100 trains, every train 100 cars, every car 100 tons, every ton 100 sacks, every sack 10,000 grains. And that's what cities get from trains. Some politicians lacking brains said in voices dripping sweet, we don't really need these trains, railroads all are obsolete. They're union strong, it makes demands, they guard their yards with railroad dicks who kick our cops clean off their lands and do not like our politics. As I was going up from town, I met the grain trains rolling down. Every day 100 trains, every train 100 cars, every car 100 tons, every ton 100 sacks, every sack 10,000 grains. And that's what cities get from trains. So the politicians passed some laws to screw more money off the trains and deeper dip their pudgy paws in more control of railroad gains. The railroad said, get off our land. They went on strike to show their peak. The grain trains stopped their rolling and the city starved within a week. As I was going up from town, I met the grain trains rolling down. Every day 100 trains, every train 100 cars, every car 100 tons, every ton 100 sacks, every sack 10,000 grains. And that's what cities get from trains. Hunger riots burned and rose and battered down the State House door, and all those fat politicos were killed and eaten by the poor. And with the city out of joint and no more politician men, the railroad said they'd prove their point and sent the grain trains down again. As I was going up from town, I met the grain trains rolling down. Every day 100 trains, every train 100 cars, every car 100 tons, every ton 100 sacks, every sack 10,000 grains. And that's what cities get from trains.
Good morning, Minecraft. Wandering Beekeeper here, running about an hour late. Sorry about that. The cat boxes would not wait. You know how that goes. So, here we are. We are back. We had a 1-week hiatus, during which I did rather a lot, but was also away from the keyboard rather a lot. We had a family retreat last week and worked out some stuff that should have been worked out years ago, but hey, better late than never. We've got people getting along better. Any positive outcome, you know? So, got things going there, got things going here. Speaking of which, let's go on and get this show on the road and get this moving. There's not going to be a train in today's episode. There will, however, be nuclear power. We are back in the electrodynamics world. I'm going to be focusing on electrodynamics for a while here, working through the various mods in the suite. I'm also about to put in a pull request and formally become one of the people contributing to the project. So I'm really happy about that and really excited about it. This has been a good community to fall in with. It's a really strong mod with a lot of active work being done on it. Let's look at what all we've got going here, because, I mean, we've been here before, but this is a very lively place here. So we're going to stop for a moment and just, okay, we've got the low power equipment here. Sounds like our mineral grinder or something. No, that's not the grinder. That's the, right. We're going to be hearing that noise again. That's the hydroelectric generators in that cobblestone enclosure in the next room. We're going to be hearing that noise a lot. That's just one of those things. Oh, storage is doing just fine. We've got 2 drives full there and a fluid tank full. I've yet to figure out how to use a fluid from fluid storage in a recipe in refined storage. If anybody watching the VOD, I don't have any live viewers at the moment, just the bot from Coffee. But if anybody watching the VOD knows enough about refined storage to tell me how to substitute in a fluid, problem being that the patterning doesn't allow me to bring fluids in unless I go to a processing recipe, and I don't want a processing recipe, and I've tried doing a processing recipe that put water into buckets and made water buckets, and it didn't work. And so, yeah, if you've got an idea, it actually would be appreciated. Feedback is a good thing when it's positive. Our coal generators there augmenting the electrical power coming from the hydroelectric generators. Let's pop upstairs a moment. Have a look at various other things. Oh yes, there's quite a lot going on here. We'll be in there in a few minutes. Be patient. Let's go back up to the MV equipment room. We've spent rather a lot of time in this room already. Nothing active going on right now, but I have put in a double mineral grinder and a double wire mill, both running on 240 instead of 120. So I've got much more capability here now with processing. I've still got a choke point with the hoppers. They only pass 1 item per tick, and that's being a bit of an issue. It's choking my industrial production a bit here. This is over here where I am making iron sulfate, which is needed for one of the nuclear processes, for one of the fuel processes. So we're running sulfuric acid over a block of raw iron to create iron sulfate and hauling it in canisters off. And this is just where we're making the sulfuric acid, passing water over sulfur trioxide. And hauling the iron sulfate off to the nuclear facility. Nuclear facility means that I need to change clothes. I'm currently in the combat suit, which is a wonderful device, the Electrodynamics combat suit. I'll turn off the night vision goggles and let the night vision fade so that I save power. I don't want to put this away with the still running. Take it off. Pro tip, if you take the helmet off, with the night vision still active, it will continue to drain its battery while it is in your active storage, while it's in your inventory. So make sure you turn the bloody thing off before you remove it. And we'll switch out for the reinforced hazmat suit, because I'm about to head off into radioactive territory. Without this, I'd be dead, and I'd be respawning in a matter of, a few seconds. This is hazardous stuff. This is the reinforced hazmat suit, as you can see. Shroud, leggings, and boots. Shroud is an interesting word to pick for it instead of chest plate or whatever. That's an interesting word to pick, and we're just going to let that sit. The reinforced hazmat suit, it won't take an unbreaking or mending enchantment. I have to spend experience and use lead plates and an anvil to repair it. Let's get on with this. Nuclear 1, fission. Pow. Here we are. at the Nuclear One facility. We've seen it before. Here is our fission reactor. Oh, here's our fission reactor. Let me move away from the hydroelectrics for a moment, so not making too much noise. There's our fission reactor. It has produced the deuterium and tritium that we need to fire up the fusion reactor. Up here we have a fuel reprocessor and a radioactive processor. These use iron sulfate or sulfuric acid to process various things, making thorionite into thorionite dust. Also, pro tip, don't carry thorionite dust in your inventory for any longer than you absolutely must. It'll eat your suit and you'll die. Okay, this is getting to be a bit much on stream. Let me go to options and to music and sounds and bring the master volume down to 25% for a few minutes here. There we go. Bloody hydroelectrics, they're noisy as hell. However, they do produce rather a lot of power once you put a stator upgrade into them. Got that taken care of. You've seen this bit of equipment before. This is the nuclear fuel processing. We are currently processing raw uraninite into yellow cake by passing water over it in a chemical extractor. We've got a bit of speed applied. The yellow cake can go a couple of places. We could bring it over here to the nuclear boiler and boil it in hydrofluoric acid in order to send uranium hexafluoride to the gas centrifuge so that we can extract U-235, U-238, and fissile dust, all of which are terrifically dangerous. Always check your suit. This is your dosimeter, by the way. This progress bar here is your dosimeter. Watch this. When it gets down low, you need to get the heck out and go repair your suit. Chemical mixers here are producing sulfuric acid and hydrofluoric acid, you know, the usual highly toxic crap. Hello! I wanted to tell you that your last stream inspired me to download and play Minecraft for the first time. Brilliant! Welcome to Minecraft! So glad to have inspired you. That makes me feel good that I've turned somebody else on to this. I hope you're enjoying it. If you have any questions, there's a brilliant community that can help you out. And I'd love to see you post what you're building. By all means, you know, post what you get to what you've got together that you're willing to show off. Love to see it. So we've got yellow cake here. We're not going to put it in the nuclear boiler and boil it in hydrofluoric acid. Wow, that's a thing. We're instead going to put this yellow cake in our pocket for a brief moment only, let me tell you, and don't mind if I keep slipping into the British accent. I'm sorry. I was doing a thing this morning with writing, and was working in a lower middle class northern accent, and it keeps wanting to creep back in. We've got lithium dust, salt, thorionite dust, bloody dangerous stuff, and yellow cake out here. And we've got an MSR fuel preprocessor. This is a new device. We're feeding it hydrofluoric acid. We've fed it lithium dust. We're going to look at the recipes here because there are only two recipes. MSR, by the way, stands for molten salt reactor, which is where we're going next. There is, in fact, a molten salt reactor already built. I haven't fired it up yet. Be all sorts of fun. But it makes UF4 salt. If we put in lithium dust, thorionite dust, and yellow cake, both of those are quite radioactive. it'll make UF4 salt, which is the fuel for the molten salt reactor. Little different recipe: sylvite crystals, salt, and lithium dust, none of which are radioactive, thankfully, and again, hydrofluoric acid. And it produces Flanax salt. Flanax salt is the coolant for the MSR. And so, we're going to want rather a lot of that. The more you put in, the more cooling is done. Right now we're set up with lithium, and we don't have any sylvite here. So I'm going to grab this thorianite and the yellowcake that we just made, briefly holding both of them, and get them into the preprocessor very quickly, and then go check my dosimeter. Make sure that I've still got green bars on my suit, because this is bloody dangerous. See if I can get the Geiger counter to work today. It wasn't wanting to work the other day. It should be showing me. It's not. I'm rather perturbed by that. It should be showing me the rads per hour, and it's not, and I don't know what's gone wrong with it. My Geiger counter stopped working. It's important to have everything close by, huh? Oh, absolutely. You don't want any of this stuff out of a box or a machine any longer than you absolutely need to. This is why I built the nuclear facility in a small building like this, and everything is so crowded together. You want to keep it all very tight, keep your radiation in a small area. Be very careful with it. This will absolutely rip through your suit in a matter of very short time. All right, we're done with the thorianite, and we're done with the UF4, and we're going to put the thorianite there, and I've got UF4 in my pocket, which means I need to get out of here. And we'll go to the molten salt reactor. And here we have UF4 salt, and I'm going to load it in and get it out of my pocket. Check my dosimeter. Okay, we're good. Molten salt reactor. Molten salt reactor does not require a water bath itself. The freeze plug stores Flanax salt, which is then used for cooling it. Reactor core. The freeze plug is currently off. Gotta take care of that. The molten salt supplier over here, which we feed this thing. This is the preheater for the fuel. We drop the UF4 salt into here, and it melts it and then feeds it into the reactor. Control rod. Got to be able to damp the reaction if we need to. The ceramic pipe here is a heat pipe. It carries the heat from the reactor up to the heat exchanger there. We've all seen a heat sink before. It looks very much like a heat sink. And it's directly under the main turbine. So that heat exchanger is going to boil the water in that enclosure and drive all those steam turbines, because at its heart, nuclear power is steam power. Now, I think I've got a problem here. I need to check the manual on something. The manual for Electrodynamics is one of the better written I've seen. It's one of the better put together. I do like that they've got such extensive in-game documentation. Documentation is critical, and for an engineering mod, a tech mod, it's really necessary. You can't just point people to JEI. Come on. Besides which, we're mucking about here with nuclear science, which starts with a chapter on radiation, telling you exactly how many rads you're dealing with There are some designs for fusion reactors that convert fusion energy directly into electricity without the lossy steam power conversion. This is true. Unfortunately, the nuclear science mod doesn't have that design. Everything comes, but fission, yeah, it's steam. Yep. Which vastly amuses me because, I mean, steampunk is kind of my thing. We've already seen that all, and you know, I've made the point of it. One moment. Oh, we do have an adult content warning for several reasons. So yeah, the thoriumite. Thoriumite ore puts off 500 rads, which is a bit much. Thoriumite dust. Let me see if I can find it here. Thoriumite dust puts off 2,000 rads. The yellow cake was only 300. It was much less of a problem. The thoriumite dust that we were mucking about with is 2,000 rads. That's double the radiation of a pellet of U-235. But only half of that of plutonium tetroxide. Yes, this mod does include mucking about with plutonium. It does not include the chemical toxicity of plutonium, only the radioactive toxicity. But isn't that fucking enough? I mean, really? Come on. We don't need to deal with poison as well as radiation. Wow, you will need a hazmat suit to avoid getting radiation poisoning. You must be wearing a full suit. And it goes over the whole thing about how radiation poisoning works and the antidote and so forth. Steam turbines. The voltage you get out of the steam turbines is determined by the temperature, so you've got to know what your maximum, what your operating temperature is, and set your power and build your power takeoff to be able to handle that voltage. I had a fission reactor. My first fission reactor I set up with 120 volts, which was fine until I put 4 fuel rods in it, at which point it went up over up to 1400, and it went up. The temperature went up, and it went up to it kicked from 120 to 240, and my battery box exploded. Yeah, if you put too much current to a battery box, it goes boom. So you got to be real careful about that. Then it gets into the fuel system, fuel systems and so forth. And let's just go back to here, because what I actually wanted to look at was the molten salt reactor. Okay, we've got the freeze plug. Make the salt, place it in the plug. Trying to see off frozen. Wondering if it kicks on when the... I need to make sure I don't need to, of power here. The freeze plug, it doesn't show the freeze plug connected to nuclear incident. Yes, that is a phrase. That is indeed a phrase. I've had a few of those. When I first started, when I was working with Mechanism, before I built my first survival mode fission reactor with Mechanism, I spawned a new world, went into it in creative mode, used the Mechanism mod commands to spawn a fission reactor, fueled it up, gave it no coolant at all, and fired it up, and then backed up to see what would happen. It was spectacular. And yeah, the only thing I know about molten salt reactors is that if the core melts down, it melts the freeze plug, thus emptying the reactor of fuel. It's a safety mechanism. Well, I hadn't seen that. Thank you for pointing that out. I hadn't seen that and realized, oh, right. Meltdowns aren't part of this mod? But yeah, it melts the freeze plug and the fuel goes bloop. And while you do have a China syndrome, possibly, you end up with an elephant's foot. But I suppose better that than an explosion. All right. Now I'm reading through here. I haven't fired this thing up before. I'm firing it up live on stream. This is going because, you know, what's streaming if you don't occasionally biff it live? Heat exchanger. We've gone through all of that, and the control rod, we've got that, and then it goes into the fusion reactor. Looks like the freeze plug only has 2 states, off and frozen. All right, let's see. I did in fact make an extra freeze plug. Good. Let's take the extra freeze plug outside, and I'm going to just put it on the wall here so that I can look underneath it and see that it has a red port. A red port indicates power supply. I don't know what the power supply. See, it wants 120 volts. There we go. There's that. Right there. It needs 120 volts underneath it. All right. That's easily taken care of. We'll collect that, and we'll pop it back up into here. Good thing I checked over that before trying to fire this thing up. I would have had a nuclear incident with my very first molten salt reactor, and it's been rather a lot to put it together. I've put the entire thing together in survival mode here. So, we're going to knock this out and knock that out. And we're going to go get a battery box. Stick a battery box under it. And then charge it up. Off we go to the MV equipment room. Oh, while we're bouncing around, let's go and take a look here. We can actually, I think, let me think about where it is. There we go. It's behind me. No, we can't see the fusion reactor from here. Let's bounce on over here to fusion, to nuclear 3, where the fusion reactor is. I put it in a pillager tower up in the top. Took the roof off the pillager tower and built the fusion reactor up there. That puts it, as you can see, a bit of a distance from where I'm living. There's the mansion over there, which is out of the blast radius. So, off to the MV equipment room so that I'm within range of the transmitter for my network, and we need to make a battery box. To make a battery box, I must first make batteries. 1, 2, 3, 4, 5, 6. We then make a battery box, voltage 120 battery box, like that. And I don't think I have any spare 120 batteries. That's a bit of an annoyance. I'm going to need to make 2 more. Go. And we'll bounce down to the front hall, where I have a 120 volt charger, and I can then put the battery in the charger. We'll give it a moment. It's going to take a minute for these 2 batteries to charge. While those are charging, since I have a chunk loader keeping this area active, I'm going to bounce over to the MSR. Here we go. And we need, let's see, here's copper wire. It's rated up to 240 with an ampacity of 360. Shouldn't be a problem. What's the amps here? 4 kilowatts. Whoop-de-pop at 120. That's hardly anything. Tell you what, just for safety, we'll go to superconductive wire. Why not? I've got it in the bag. Let's drop it in there. And yes, it does immediately connect. And then we'll take our battery box and put our battery box down there. I'm going to have to pop this loose to make sure which direction our battery box is pointing. Red is input, gray is output. So output is now over here, and our battery... Shit! What was that? What was that? What did I touch that I shouldn't have? Something went awry there. And a bit of a shock or something. Not sure what happened. There's no current. There shouldn't be any current. Not sure what that was. I don't know. Maybe I don't know what that was. Pardon me being very nervous about it. Again, brand new here. Never done this before. All right, off back to the front hall. And we go to our charger, and our battery is getting close. Now, it's going to disappear because this is sitting on a hopper. Really should take that hopper out from under that. There we go. Let's get that hopper out from under there. I'll keep the orange terracotta as I intend to... there we go. And shift it over to there. Bring this one down as I intend to put it back where I got it. We'll bounce back to the MSR. And we'll put our orange terracotta back. And then we'll drop a battery in here. And start charging up the box. That's going to take just a moment to drain into there, but our status is now frozen. We now have power coming into the freeze plug, so our status has gone from off to frozen. Brilliant. There we go. There we go. Always pays to check over your equipment before you fire it up. Yay! Yep. Indeed. I'm reminded of a strip from the comic strip Freefall, sci-fi strip. At one point, the engineer and the robot are working on the brand new nuclear reactor they've installed in the ship to replace the old one, which was defunct. And the ship had been grounded for some time. The engineer gets the reactor put in and tells the robot, what I want you to do is watch that gauge. Tell me what it does. All right? She goes and pushes a couple of buttons, and the robot says, the gauge went up. It's in the, it's right at the top, right between the yellow and the green. The engineer says, perfect. Is it moving any further? The robot says, no, it's not moving at all. Engineer hits another button and says, the robot says, okay, the gauge went back down. Nuclear power is really boring. The engineer says, if you want to live a long and healthy life, it'll stay that way. If it gets interesting, you've got a very large problem. Okay, we are now draining here, so what we're going to do is bounce back to the front hall, and this is going to be a kickstart charge. I'm going to have to wire that battery box into the system. Oh dear, I'm going to need a step-down generator. Down. get a downgrade transformer. These are dangerous because they don't have a covering. We're in the 1.19.2 version of Minecraft here for the official Electrodynamics mod pack. With the 1.20 version of Electrodynamics, polyethylene sheet, it can be applied to transformers to put insulating shells over them so that you don't electrocute yourself if you accidentally touch a transformer. Right now, we're going to have to deal with the fact that this one's just bloody dangerous. All right, we're going to have to do this fairly quickly. We need to get this popped in and this popped out. I'm going to have to run cable here. Where am I running it to? I need to go outside and look at where my power is, generation is. Oh yes, did I mention we have a particle accelerator? We'll get to that in a moment. Completely forgetting that I don't have to go outside. I can use the internal stairway here. Okay, our power takeoff is to a lithium battery box, which means it's coming off at 240. We need a step-down generator. Ooh, bugger. Yeah. Fortunately, there's no power yet. Those are upgrade transformers. Don't want to drop on those. I need to put a block over that. There's no wireless transmitter in range. Of course there isn't. I don't have anything. I'm going to have to... here's some glass. That'll do. Glass is fine. Glass will do. There we go. Let's put that into place. And this glass is an electrical insulator after all. There we go. We'll get that insulated. Now, I need step-down generator. Need to think about where this is. That's the front entrance. The molten salt is back this way. I'm going to break this block here and cable here and here. Then we're going to go down to the corner here. See where I am. All right, that puts me down along the side there. Okay, cable will go up that way. What I've got to do here is bring the 120 down. That's a bit much. Let's, at the very least, put this into the floor. Bloody sandstone. It's so friable. Go and there. Put a channel there and get this sandstone back. Put it in down there. There. Then we'll lay our cable down in the trench. Right, we've got that done. Off we go. Upstairs, up to the top, and over to here. And we put in our downgrade transformer. I'm actually going to going to change this. I'm going to pop that cable out and that cable out. And I'm going to put the downgrade transformer right there. Aha, gray output. So the input has gone the correct direction. Good. And then take a block of glass and put it right there on top of it. Pop. There we go. Now it's secured by sandstone and glass, and I don't have to worry so much about the electrocution hazard. And now it's connected. So, once this thing is fired up, we'll have 240 volt power coming off the steam turbines into the lithium battery box. 240 volts going to the downgrade transformer, 120 volts coming out of the downgrade transformer and heading down. Whoops, this must stop. There we go. Heading down via this cable here and off to our battery box, which is looking a little peaked, and recharging it so that it can continue to supply the freeze plug. So the battery box serves as a jump start device and also as a power buffer. If something happens to the power systems up there, we'll still have power to the freeze plug for a while. Uninterruptible power source. UPS is an important thing to have. Now, there was a reason I was thinking about going back. What was I doing? We're going to do a couple more things here. I'm going to go to the front hall. I'm going to put this away and this and this. That's what I was doing. There we go. I knew if I had to look at it. I'm going to start that doing and get that, and let us get just that little bit more power stashed into here. There we go. All right. Freeze plug is frozen, and thermal bonus is 200%. We've got 64 Flanax salt. I'm going to take our control rod, and I'm going to bring it in. Let's see. Bring it in. I'm trying to remember. Yeah, you use shift to back it out. There we go. Click to bring it, right click to bring it in, shift right click to bring it back out. I'm going to bring it in. I'm going to go on and bring it in all the way here. Bring it in. Let's bring it in halfway, just safety. Let's bring it in halfway and think about extending it out later. Check the dosimeter and get 1 tablet of nuclear fuel. Load that 1 tablet. Oh, our molten salt needs electricity as well. Where's it supplying from? It's supplying from the bottom. Got it. Got it. See it. Right. There we go. Well, we've got the cable. Just a matter of, there we go, and it connects. And it requires 120 volts. It's now ready to go. We'd better get this going before that runs out. Molten salt supplier. Here we go. All right, waiting for it to start. 4 kilowatts, 120 volts. Waiting for it to charge. It should be kicking off. This is going. Have we just got not got enough voltage here? Maybe we don't have enough megajoules supplied yet. I don't know. Transfer is 43 kilowatts. That may not be enough. All right, we're taking that out. Move the fuel. All right. I'm going to cut this cable here. I'm going to put another one over here to power that one. Power that. All right. Are we ready for ignition? It doesn't appear so. Does not appear so. I don't think we've got enough jump start power. So what I'm going to do here, I'm going to make another battery box. Put it on the other side. Okay, batteries. 1, 2, 3, 4, 5, 6. Battery box. Pop. And one more battery. Down to the front hall. Go look at our charger, get that put in it, take this out. Back to the MSR facility. And we'll pop our battery box on. Go on and connect it up. There. So that it's connected to the recharge feed coming in. And then we'll want to put a battery in it. There we go. Start charging. Oh, hi! It lit up. Look at that. As soon as it did that, it lit up. Ha! Apparently not, yeah. Yeah, we seem to be much closer here. All right, needed its own power source. Let's bounce to the front hall. Go have a look here. I'm going to charge another battery and drop it in just to be covered. I don't want to run out of juice in either of those systems. Okay. This is something for the guidebook. Now, I'm currently working on the Electrodynamics base guidebook. Haven't put forth a proposal even to work on the nuclear science guidebook. But yeah, the illustrations need to show power feed going to the molten salt supplier and to the freeze plug. Gonna need to make a note of that and maybe say something about it on the Discord. Our guidebook did not tell us that we needed power supplied to either of those devices, and the illustrations don't show it. Place a freeze plug, and then place a reactor core on top of it facing the green port of the core. Place a molten salt supplier so its green port faces the cores. Doesn't say anything about supplying power to either of those devices. Doesn't show them with a power connection. And doesn't... Oh, there. It does show the molten salt supplier in a powered state here, but we can't see that what it's connected to. There we go. We do see the molten salt supplier connected to what looks like a creative power source there. And wiring extending down. We've got one illustration here that shows that we do in fact need to have power supplied to these things. That one illustration is all we've got to go on, and it really, that's got to be fixed. All right. Going to have to do something about that. The guidebook for nuclear science does not say that you need power. Really probably ought to. Okay, there's our second battery. Off we go back to the MSR facility. And pull this out, put this in. Put this in so that we've got a fresh battery in both. Okay, status is frozen. It's lit. Let's drop some fuel in it. I think we may be ready for ignition here. Let's give it a try. Holy crap. Whoa. That was the turbines kicking on. We are in business. We have molten salt in the reactor being consumed. Status is good, no warnings. Freeze plug is cooling. We are go. Look at that. And we've got power rolling in as expected. Brilliant. I'm going to take the battery out and see. All right, we're not quite getting it. It's not coming in. we're going to back the control rod out a bit. Come on. Empty hand. Empty hand. There we go. Sneak and click. And back it out one. Bubbly, 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 bubbly. Up there. Steam turbines going. Let's head up here to where the power generation is happening. We've got nothing coming into there. It's all going to be going off this direction, isn't it? Where is it going? Is it going? We may not be running hot enough to get power up here. I don't think we're running hot enough yet. Oh, bugger. Damn it. There we go. Can you give it one more click? Yes, okay. Take it all the way out. Status good. We should be producing 240. Not seeing where the power is going. Who knows? Trying to see where the power's going, if it's going at all. Alright. I'm going to do something here. I'm going to remove that. So the power is only going around this way. If it's generating at all. It should be. Please tell me my battery box isn't backwards. Oh dear God. Rotate. Anything? Anything? Thought I had that set up right. Why am I not getting electricity? This is still ticking down. It's not good. Alright, the one for the freeze plug, let's go and drop the battery back in. I don't want the freeze plug running out of power while I'm trying to figure this out. Why am I not getting power? This didn't seem to be backwards. That wasn't. I know the battery downstairs is pointing the right direction because it's delivering power to the system here. Still ticking down. We're going to go back to the front hall for a moment. The MSR should be out of range of the... Let's get that started. Should be out of range of the chunk loader. I am perplexed. The turbines are running. Alright. Fine. I'm taking the control rod off entirely. The design doesn't require it. I have become Steve, fusion scientist of Minecraft worlds. Well, I'm not playing Minecraft Steve here. I'm playing a custom skin, but okay. Let's see. What is bloody going on with this? I should be getting power coming in, not out. Why am I not getting electricity here? This is just baffling me. What did I do? Okay, the turbines are running. It's nap time for me. See you later. Good night. See you around. Thanks for joining. Thanks for being here. It's always appreciated. my multimeter? I'm pretty sure I have a multimeter. Thought I had a multimeter. Oh, bloody hell. All right, off to the front hall. Let's look in here and see if I threw it in here. Should have a multimeter, damn it. Multimeter, handheld multimeter, make the handheld multimeter, give me the multimeter. Alright, battery. Check the battery. Battery is not quite done. I'm going to wait on the battery because it's almost done. Well, partial success. I've brought the MSR up, but I'm not getting electricity off it. Bit of a question. Let's get back here with a charged battery. Although really, let's not put it in the molten salt supplier. Don't need to keep that powered up. Let's keep it, put it in the cooling system because that needs to be kept powered. Whew. Be bad. There we go. Now, Mr. Multimeter. There's a dead cable here. Let's see. Trace back up here. Classic engineering. Classic electrical engineering. Tracing with the multimeter. Alright, we got 120 volts here. No question about that. We got nothing here. Why do I have nothing here? I've got... Alright, let's try turning the transformer around. Nothing here. Nothing here. I'm not getting anything into the battery box at all. Alright, we're going to cut this. We'll leave that alone. I'm going to go on and break this. Whoops, I think it despawned. Oh well. Not really an issue. There, we'll save that again. Now, Mr. Multimeter. Battery box has got the red end pointing this direction. Turn it about. Gray end is now pointing this direction. And we're getting nothing. I got 978 kilowatts right there. At 120 volts. It's at 100. Why is it at 120 volts? Why is this thing is putting out at 120? Bloody hell, there's my problem right there. It's putting out at 120. Oh, no, it stopped. There's the problem. I don't need a downgrade transformer here. What I do need is to rebuild this whole bloody thing. Oh, bother. I'm going to have to rebuild this whole thing here. All right. Let's back up a second. Let's just back up a second. Before I go ripping out anything more, bloody thing is putting out 120. Head downstairs. Let's check our battery boxes here. That's about dead. That's an empty battery. Let's recharge these and fire it back up, and then put the multimeter back on the cabling. That may be my problem right there. Is that wait a minute? It's saying 120. A 240 battery box isn't going to take anything from a 120 line. It's not enough voltage to get its attention. Bloody hell. Alright. Let's go on and make the necessary things for pushing this up a bit further. Go. Alright, there's me another upgrade transformer. Not going to need the downgrade transformer. Put it away. Alright. Keep the control rod, but I'm going to put it in the backpack. I've got it if I need it, but I don't think I'm going to, really. We're going to sit here and charge batteries for a minute. Hum hum. Hum hum hum. Let's see, 00 Ella. Let's look at you and see what you've got. Tell me about your account. Oh, we're charged. Pop the next one. Go. Currently live. Okay. Here we go. Helps to go through and check on a few of these every now and then. Look at my users in chat. Make sure we don't have any that have only been around for 5 minutes, you know? Alright. Interesting that I have so many more users in chat than I have in actual viewers. Getting there, getting there, getting there. One of the reasons why I don't usually do as much playthrough as I do of showing the finished product is that some of these tech mods take a great deal of patience. You've got back to the MSR facility, and we'll drop one of these batteries into the freeze plug, and I'm going to hold off dropping anything into the molten salt supplier. It's still powered, interestingly. Let's just let it be, and meanwhile we'll work on this. Now, Since it's still powered, let's go and fire it up. I need to put a multimeter on the cable again. That's a whole thing. No, it's not actually powered. All right. That is and has juice coming in. Let's drop the battery in. Here we go. Boom. Not a good word. Not a good word to use. Molten salt supplier. Okay. It's working on it. It's working on it. That's going. We've got another battery to put into that. I want to get upstairs and get this multimeter onto the cables. $120 volts. 120 volts. Son of a biscuit. There is my problem right there. Take this battery box here and stick it here and whip it around so that it's got the right end, and presto, we got power coming in. So we're going to come down here, and I'm going to put in the first of the upgrade generators because I'm now going to need 3 of the bloody things. And the second one, and I don't even know what I'm going to do here. Got a bit of sandstone. Let's put our sandstone here, and here, and here, and here. And we're going to cable there. I'm not connecting that yet. To there, here, to here, to there. I don't like that at all. We're going to pop that. We're going to pop that, and we're going to put cable here, and we'll put the upgrade transformer directly onto that thing. Let's cut that, make sure we're yep. Turn the right direction. There we go. So 120, 240, 480, 960 into the carbine battery box. That whole area is now excessively dangerous, and I think I really ought to run myself out of glass. Back to the MSR. I need to get this connected up. All right. Here we go. We're about to wire this together. Multimeter. 120 volts. 120 volt, fully stocked. Feeding down to 120 volt equipment down here. We now have power coming in. And here, take out the empty battery, and we've got power flowing in. Excellent. Excellent. Reactor systems are now self-maintaining. Going to drop another UF4 salt into the molten salt supplier. There we go. Oh, we got fissile salt now in the output. Got to be pulled out and put in this barrel here. That one has the Flinic salt for the freeze plug. Freeze plug, doesn't seem to be using it up yet. Good. Brilliant. We're now a bit more fueled. Status good. Warning none. We have power to the battery boxes, to our buffers, just in case. It's time to cable up the high voltage. So 120 coming out 240, coming out 480, coming out 960, going into the carbine battery box. We're using superconductive wire all along the way, so we should generate no heat from resistance. I have glass that I really ought to put over on top of the excessively dangerous bits here. Let's go on and get them insulated, shall we? Down here, and I'm going to put a block here and a block here, and yeah, let's just enclose that. Enclosing the high voltage system seems like a really good idea. You know, something that I think the folks in the industry would just take for granted is going to be done. Okay, insulation enclosures are put in. All that remains is to connect the cable. Trust in the science. No, I don't believe in science. I trust in it, but science does not require faith. Well, again, not totally sure where the power's going. I didn't put buffers here. That's a problem. Alright. I need to redesign this. We're going to cut that. We're going to break the glass. Take this one out of the circuit. Got the cables there. So we've got from here, we should have 240. We need a 240 battery box. Happen to have one of those. 240 battery box. Turn it around so that the gray port is on this end. 240 battery box puts out here, and I need a 480 battery box. I've got one. Okay, so from there, maybe putting it over there. From there, we're going to have to go, I'd like to put it there. I need that, and then I need the battery box, and then I need, right. Alright, what we're going to do is we're going to hang the wire out in the middle into open space a bit. Next thing to go on is an upgrade gen, a transformer. There we go. Alright, we've got the gray end pointing this direction. So we're 240 coming out of there. We'll be 480 coming out of there. So from this point, I take my 480 battery box, put it on, turn it around, just pointing the correct direction, drop a bit of cable, and then I can put my 960 right back where it was. I'll actually want to cut that cable to make sure that it went on. Aha. the correct direction. Red port should be facing gray port. All right, let's try this again. Diddly squat. Oh, there we go. We're getting 480. We're not getting 960, but we're getting 480. I'll be happy with that for right now. Let's do the multimeter thing here. What's going on? We've got 480 there. We've got 240 there. We've got 480 coming out. Should be going here to 960. These battery boxes are all 960s. We're not getting any power to the particle injector. It's stopping at this battery box. Thinking maybe I need to go to the ceramic superconductive here. Alright, we're going to cut that wire. I'm not jumping down there after it. Well, I can there because that's not connected to anything. That one and that one are the dangerous ones. Let's put glass and glass. Don't want an accidental touch. The particle accelerator we'll get into if I can get power to it. We'll see what happens. Right now, we're accumulating power at 480 volts into a carbine battery box, which is excellent. We've gotten several steps along the way. Turbines are running. We've got the molten salt reactor up and running. I've got power generation going. We've got it flowing at least a certain distance, and the reactor itself is self-sustaining at this point. It just needs more salt. Check my dosimeter. And I'm going to grab three more salt here, but I'm not necessarily going to put all three of them in. Let's look here. We're very low. I'm going to put one salt in. Creates a fissile salt, which in the waste products, we'll pop that over here. Check that. Put in the next one. Get that. And one more. There we are. We are now up close to a full reactor. Status good. Warning none. Nuclear power needs to be somewhat boring and tedious. If it gets exciting, it's bad. We are running at 989 C. There's the key right there. We're not topping 1,000 here. Because of the temperature this thing runs at, it puts out 120 volts. It says so in the manual. I just didn't quite put together everything that's in the manual. This is my first molten salt reactor ever. This is my first playthrough of the mod. So, yeah. Pardon me if I make a few rookie errors. But we are running just short of 1,000 C. We are chugging along. Look at that. We've maxed out. It can't hit 10 because there's throughput. That one's also. We're in excellent shape there. Do I have any trap doors? No. Got quite a... Yeah. I only carry so much stuff, you know? My dosimeter. Back upstairs. All right. That's all good. That's all good. We're good up to that point. Do I have... That is ceramic wire. This is steel fluid pipe. I don't think I have any ceramic wire. Sometimes these things become a problem because of a wire mismatch, and you have to put the same wire on both sides. We're feeding into 960. This should output 960. It's receiving 480. It should output 960. Now, if we're not getting power on through, it's most likely because it's not the right voltage. And I'm thinking I just need to go to the heavier wire. So, but in the meantime, we're still capturing at 480. I like this. We can let that build up. We're going to want to build up here. And I need to put a lever on that and turn it and make it sure it's turned off, so that it doesn't immediately try to glom the power out of the... Oh, I had three... No, those are carbines. Okay, fine. Back to the front hall. Let's take a moment. Drop a battery into charge, and put the charged battery up there in the... and glass up here. Okay, got batteries going. Do I have ceramic wire available? Oh, the ceramic insulation. There we go. Ceramic superconductive wire. I have 3 pieces of it. It's bloody expensive to make. I do have 3 pieces of it. I can try connecting the battery box to the transformer with the ceramic wire, so that it's got ceramic on both sides of the transformer. And we'll see if that fixes the problem. Give that a try in a moment. I do need to think about other things as well. Do I have... What have I got? I had some stuff processing over here. Apparently it's done. Got anything processing at the moment? Whew. Making the salt we already looked at. We fired up the reactor. Let's go off to the fusion here for a minute and go have a look at it. Around outside here, we can go up the ladder, but that only lets us see a certain amount here. There's too much stuff in the way. We really can't get up there on this ladder. Unfortunate. Could try the vine. Nope. Vine goes up to there, and alright. I may have to go like creative mode here so I can fly around and show you this. This is the underside. This is where we light it off from. There is, as you can see, a fully charged carbine battery box delivering 480 volts and with 80 megajoules stored and a bit extra just in case. It takes a big charge to set off the fusion reactor. It becomes self-sustaining once it is lit. But, you know, you've got to have that power available to light it off in the first place. Over here, we have deuterium and tritium. We load one of each of these into that fusion core up there just by simply Excuse me. Too much blood in my caffeine stream. Need to refill the mug. Mm. Mm. About time for second coffee, I think. There is no interface on this thing. If you right-click it with the deuterium cell, it just loads it. It loads it. Very simple. Can't get up there from here. Let us go out to here, and I'm going to very briefly game mode creative, and so that I can flit about. And let's have a look at this beast, because it is a fucking beast, let me tell you. It's almost like some sort of arcane glyph, you know? There is a symmetry here to the arrangement of the cable and to the arrangement of the turbines. We have 4 large turbines. We're going to be coming off here at serious voltage. I'm set up to capture at 480. There are 4 large turbines and a host of smaller ones surrounding the fusion reactor core. And yeah, it's an entire thing. There's a layer of electromagnets, an outer shell of electromagnetic glass, and then more electromagnets which you can't see because they're underwater. The water is directly on top of the electromagnets. The brick is to retain the water, keep it from flowing off. And then there are steam turbines. Lots and lots of steam turbines. I built this in survival mode. It took a while to craft all that. Just to make the components. Ooh, is a thing. So let's land here and go back to game mode, survival, and I'm going to go fire up this beast. Because it's ready to fire up, as far as I know. Got my ignition charge set up here. We've got power for ignition. Let's pull out a tritium and a deuterium. Just one of each. I'll take a tritium here, and we'll check the manual. Because we always check the manual before we fire this thing up. So, note the turbines will operate at 480 volts. There's our confirmation. We will be taking power off at 480. I've already got set up for it. Requires 50 kilojoules per tick at 480 volts to operate. The initial energy must come from somewhere else. That's our battery box, 480 volts, and it's fully charged. We do, in fact, have the wire connected to the top. I followed the arcane sigil here precisely. Used brick instead of whatever they use, but what the heck. To add fuel to the core, right-click a cell on it. Can be done through the convenient hole left in the bottom. So we're going to simply right-click a tritium cell. Boom. And a deuterium cell. And we see this. Okay, it is pulling the charge for here. Charge is pulling. I think I would very much like to be elsewhere. I don't know. Alright, well, it pulled charge and then stopped. What's going on here? Not hearing turbines. What's going on here? I need to be able to fly. Let's split up here. The turbines are not running. How much? I wonder if it takes more fuel. Oh. Tritium. Deuterium. Back to survival mode so that I actually used up the fuel. It pulled charge and then nothing happened. Sure. So I'm going to hit it with all of the tritium and all of the deuterium. And again, here we see that pulling charge here. Seeing a lot of megajoules transferring. But I'm not hearing the turbines. I'm wondering if I just have to wait for enough megajoules to transfer. Alright, the carbine battery is flat, or charge it late. We are still drawing considerable amounts of power here. $50 kilojoules per tick. 172 kilowatts. That shouldn't be a problem. I've got the ceramic superconductive wire there. Yeah, we're transferring at 172 kilowatts here. That thing should be going, isn't it? I need a ladder up there that I can actually use. I have to build one, or build a stairway or something. Right where I could put it. Huh. Arg. Alright, this is getting on my nerves. And nothing there. See, it says something about deuterium and tritium. I don't think I can get down in there close enough to... But... Deuterium 46? It's consuming the deuterium. It's down to 46. Why isn't it running? Why isn't it igniting? What have I done wrong here? something not right here. How I've built this. Not sure what the problem is. Turbines aren't kicking on. There's no power here. But the fuel itself is being consumed. I can see that it's down to 44. There, 43. It's consuming the fuel. But it's not producing anything. Why aren't the turbines going? All right. I think the turbines are supposed to be above the water? That thing's supposed to be in between the two layers of electromagnets. And visible there. Did I place it too high? Hold on. I can check this. No, it's visible right there. It's rather expected, I think, that this... Well, maybe that's supposed to be filled. Alright. Cover the top of the electromagnets with water. And... for spinning turbines. This looks like they've put the turbines above the water level. Alright. I'm going to have to do a complete rebuild on this and move the turbines up. Alright. I'm going to do a complete rebuild on this and move the turbines up out of the water. That's going to take a while, so I'm not going to do it on stream. Let's bounce back to the MSR. Put myself back into survival mode. Check my dosimeter. And go see how our reactor here is doing. It's burning down the last of its fuel. We're fully charged there. We've got over half a box of electricity up here. That's an interesting phrase, half a box of electricity. Let's try connecting it with the ceramic cable. $480 volts. Nothing. Nothing coming out of that. Turn that around. Take a meter on it. Meter reading. Nothing moving. Nothing moving. Nothing happening here. I got nothing. Alright. It doesn't like the ceramic superconductive, I don't think. What if I try regular superconductive on it here? Let's... yeah, pop that. I didn't mean to pop that. Bloody sandstone is so friable. Alright, I'm going to take the... ceramic wiring off of that. We are pointing the right direction with these battery boxes. That's pointing the wrong direction now. We'll turn it about. There we go. Gray is out, red is in. Insulated superconductive wire, and let's try to connect that. Right. And then we're going to connect this and see what happens. Shit fire. Ooh, that was close. Oh lordy. Oh lordy, that was close. Oh my gosh. Oh my gosh. Ooh, that was close. Okay. The good news being, it's a dead cable. Theoretically, it should be carrying 960 volts, but it's not carrying a damn thing. We've got 480 here. We should have 960 here. And nothing's happening. Why is this upgrade transformer not upgrading? That's got power. That will carry it. This should transform it and bring it up to 960 from 480. But it's not outputting anything. Our transformer's not going. Rotating the transformer has no effect as expected. It was turned around the right way the first time. Alright, disconnect the battery boxes from the particle accelerator. Well, you should have a switch or something there anyway. Alright. So we should be going straight through to just this battery box, and we're not. That transformer is not transforming. Why not? There is only one model of upgrade transformer. There aren't any upgrades that can be applied to it the way you can to a battery box. I think our reactor has run out of fuel. It's not a problem. Alright, we're not getting anywhere here. Let's try searching for battery. Circuit breaker, yeah. Where the heck are the battery boxes? Transformers. Oh yes, if you try to run too much amperage through a wire, you can't risk setting it on fire. Except single phase. Fresh current, grid tools, circuit breaker. Where the heck did I miss transformers? Where did I miss transformers? Section 6. Here we go, transformers. Alright. Offers two transformer types, upgrade and downgrade. The upgrade transformer steps up voltage. The base upgrade variant has a fixed turns ratio of 0.5. They will shock you if when touched if they are live. We already know that. We already know it's a fixed turns ratio, so the upgrade transformer from 480, it's a 0.5. It should be turning out 960. Still getting a hum of electricity here. We're still processing a lot of power through here. And yet, this wire and this wire remain dead. I do not understand. That's just about emptied itself out. The transformers produce a hum, which I think is a nice detail. Yep, and there it goes. Quiet again. All right, well, our molten salt reactor is working and it is producing power. We're just not getting that final step up to the battery boxes and to the power level needed to run the particle accelerator. Okay, it's not being solvable and we're hitting the top of the hour. So that's going to be taken care of offline. Check my dosimeter. And we are in good shape here. We have plenty of fuel over here. Run this as long as I need to. This beast is down and is going to need a rebuild. I'm going to take the turbines and move them up above the water level, above the water, instead of having them immersed in it the way they are at the other reactors. And we'll see if that does anything. Get them up off the electromagnets and see if there's room for the water. I don't know. That's going to have to happen offline. Not going to happen here on this. Which means that we are coming to the end of another session. We are hitting the top of the hour. We've gone through nuclear fuel processing. We have successfully fired up and captured energy from a molten salt reactor. We've learned a few things about the fusion reactor. We've gone over power systems, done a lot of engineering work, run around with a multimeter for a while. You know, it's been a thing, but we are coming up to the top of the hour. And I normally go 2 hours. I started late today, so I'm finishing late today. Let us roll over. Would like to thank people who've been here. Mux, thank you for joining. Always a pleasure. And the rest of you in the chat who are not viewers, your companionship on this journey has been appreciated, as it says on the screen. I am pleased to be a member of the Truck Community Streamers. Our schedule is on the screen right now up at the top there, schedule.truck.community. We have stuff going on pretty much every day, various hours of the day and night, all sorts of things going on. Right now, I'm going to send a raid over to Willow Mist. Willow Mist is one of our streamers, and she is running Fortnite. So, thank you for joining, and we will see you next week. Same bat time, same bat channel. Hopefully, I'll be on schedule next week with more Minecraft Trains and Tech, 8 a.m. UTC -6 right here. Just follow me. And I will be back tomorrow night, Sunday night, at 8:30 p.m. UTC -6 with Roots of Pacha. Brilliantly written farm sim in which a Neolithic clan invents agriculture. It's been an absolute delight, and we're continuing to play through that. We're just now up to spring of the second year. Going to be a thing. So thanks for joining me, and let us trigger a raid here and fire it up. Rating in 5, 4, 3, 2, 1. Launch.